So let's consider the following problem about a portfolio which consists of multiple risky assets. So you have got Safina, who owns a piece of land located near a hill, and the return to this land is a random variable which depends on the amount of rain received in that region. So in rainy years, the returns are good, and in years in which rainfall is inadequate, the returns are poor. The market value of this land equals 5,000 units, and the expected return from this land that Safina owns equals 500 units per year with a standard deviation of 100 units. So we said that rain is good for this piece of land, so we can also quantify that. So what we mean is that every inch of rain above the average is going to lead to 100 additional units of profit, and every inch of rain below the average is going to lead to 100 units less profit than the average one. So this is the initial situation. And actually, Safina also has 5,000 more units of money available that she can use to buy another piece of land. And she has two choices, which we are going to call L1 and L2. And each of these land has the cost of 5,000 units, right? So L1 is a land which is located on a land, on an area that in an area that never floods, and this actually yields a return of 500 per year no matter how much it rains, right? So if it costs 5,000 and it returns a 500 per year, so this is basically 10% per year without any risk, right? Then the second land is located very close to the river, okay? And so therefore it's going to be affected by the whether the river has a flood or not. So this is going to give good yields in the year when the weather is dry, because in those years there is no flooding of this land. And it's going to give bad yields in the year when the river floods. So the expected return from this land is also 500 units per year, and the standard deviation is 100 units. And because this is going to give you a higher return when the river does not flood, so every inch of rain above the average is going to lead to 100 units less profit, because profits go down here because of more water coming in from the river. And every inch of the rain below the average is going to mean that there is an additional 100 units of profit compared to the average, right? So this is the situation that you have here. So let's think about how to think about this question of where should Safina actually put her 5,000 units? Should she buy land L1 or land L2? So first, what's the expected rate of return on her total investment if she buys L1 as her second investment? So she already has half of her wealth in the land that she had located near a hill, and this was basically giving her a rate of return of equal to 10%, right? Because she was getting expected return of 500 units out of this investment of 5,000. And in L1, if she puts this additional 5,000 units, that is also going to give her a return of 10%, right? So therefore, the total investments perspective, the expected rate of return is going to be half of 10% plus half of 10%. And so that's therefore equal to 10%, right? What about if she instead buys L2 as her second investment? So again, we can do the same analysis. So she has half of her wealth in the first land, which is located near a hill. That's going to have a expected return of 500. So therefore, the rate of return is 10%. And in the second case, also the expected return is 500 units. So therefore, the rate of return is also again 10% because the cost is 5,000. And so therefore, it's again half of 10% plus half of 10%. And you end up again that if she buys L2, then her expected rate of return is going to be 10% as well, right? Now, let's think about the decision of which one to buy. So let's suppose that Safina has mean variance preferences in the sense that we have been discussing. So which of the two lands should buy? So here it's a bit interesting, right? Because, intuitively you might have thought that L1 is a better purchase, because if we look at L1 and L2, they both give 10% expected rate of return, right? So the mean rate of return is the same. Whereas it seems that L1 is less risky, right? Because L1 does not have the land's return depending on whether it rains or not, whereas L2 actually has the return from the land depending on whether it rains or not, right? However, if you notice, the risk that is there in L2 actually is exactly negatively correlated with the risk that is there in the original piece of land, right? Remember, the original piece of land was subject to this risk that if you have got excess rainfall, that's going to be bad for the profit. And if you have got if you have got more rainfall, that's going to be good for the profit. And if you have got less rainfall, that's going to be bad for the profit. Whereas in the second land's case, it's going to be the exactly opposite, right? So if you have got more rainfall, that's going to be actually bad for your land. And if you have got less rainfall, that's going to be good for your land, right? So these two actually help to kind of like cancel the risk exactly, right? So it's the same as the example that we had discussed about these assets A and B, where if you actually, because they are negatively correlated, if you hold them together, you are in a better position than you have before, right? So if we now compare the combination of owning the original piece of land plus L1, we have the expected return, which is 10%, but you do not actually hedge against the risk that is there in the original land. But if you purchase L2, then what you have is that the expected rate of return is the same as owning the land and L1. So we are fine in terms of that dimension, but the overall risk is actually now lower because of this negative correlation of the two assets values, right? And so therefore, if she has a mean variance preferences, then she should actually end up buying the second land versus the first land. So that's the basically answer. So this hopefully is like kind of like helps to understand this result about what we discussed about if you have multiple assets, we need to also look at the correlation between the rates of return of the assets, and it's not just enough to look at the standard deviation in this case. But we'll have more to say about these things as we move forward.